So for my Arduino code, I did all the setup that I needed to do, pin mode, digital write, delay, and the serial begin, and then I went in, defined my time constant using floats and operators, and then did digital write high, did a for loop to make it print the reads at that high state, delayed it the specified amount, and then did the digital write low, did the same thing, printed the reads, and delayed it as specified. The serial output, you can see if I set it to not auto scroll, it discharges, and then once it starts up again, it charges back up, and then eventually, once it charges, it goes back to low and starts to discharge again. So here we have the processing, and here I just added lines at the specified states and basically found what 0 and 5 was in terms of coordinates, and then from the code, and then divided that space into 5 sections. And then I added the legend and numbers, and as you can see the charging and discharging action. So besides the CSV file location, the only thing I edited in the MATLAB program to make it into voltage output is these VN voltage and VC voltage, which are just percentages of max voltage by dividing the code by the max code and multiplying it by 5. And we get this graph. So we get a nice, clear charge-discharge, like 1.5 period. So here we have the processing output for the 100 kilo ohm resistor, and it discharges much slower and charges much faster, but to a lesser degree. There it goes. And then if we go ahead and look at the MATLAB, rerun this, we're going to need new R. Yeah, there we go. So there we see the voltage does not get to charge as high. So here we have the thermistor circuit with the thermistor and the divider and the VN and VC readings, and we can see it's stabilized, and then I grab it with my fingers, and we can see as it increases the resistance with heat, it seems to logarithmically tend towards around 2 volts in the V out, and it stabilizes. So here we have the thermistor restabilized at room temperature, and I will take this spoon that was in the freezer and touch it to it. And as we can see, the resistance lowers and the voltage coming through increases. Worth noting that both of these temperature gradients, even the more drastic one like this colder one, are much slower than the original capacitor. The spoon slipped off, so that's why you saw that dip there. In testing the thermistor circuit, I believe that it behaves as intended, given that a first order step response can look something like this, which is like one of the examples that we had in our notes in class. And this most closely resembles the cold step, or the cooling step input, where you have a stabilized reading, and then as you apply the cold item to the thermistor, the resistance lowers and the voltage allowed through increases.